How is psychrometrics used in cooling system design? Imagine trying to keep a building comfortable without knowing how hot, humid, or dry the air is. That's where psychrometrics comes into play, acting like a map for understanding moist air. It's a science that looks at the properties of air with moisture in it, like temperature, humidity, and energy content. Engineers use this map to design cooling systems that work efficiently and keep indoor air just right. When designing a cooling system, the first step is figuring out the air's starting conditions. Using a psychrometric chart, engineers can identify key points like dry bulb temperature, which is the air temperature you feel, and wet bulb temperature, which accounts for moisture. They also look at relative humidity, which shows how moist the air is compared to the maximum it can hold at that temperature. This helps determine how much cooling and dehumidification are needed. Next, psychrometrics helps calculate cooling loads. It separates sensible heat, which changes the air temperature, from latent heat, which involves moisture removal. This is important because cooling coils must be sized to handle both. If they only remove heat without dehumidifying, indoor humidity might rise, causing discomfort. Proper analysis ensures the system can do both effectively. Engineers also use psychrometrics to predict how the air will change after passing through cooling coils. Due to coil inefficiencies, not all air contacts the coil surface, so the actual cooling is less than ideal. The bypass factor on the psychrometric chart shows how much air bypasses the coil, helping engineers design systems that meet target conditions. Another key use is in mixing outdoor air with return air. Psychrometrics helps plot these processes to ensure the combined air stays within comfort zones. This way, systems can bring in fresh air without wasting energy cooling excess moisture or temperature. Controlling humidity is vital for comfort and health. Psychrometric analysis helps set the right supply air conditions, balancing temperature and moisture. For example, supply air might be cooled enough to remove heat but not so much that it causes drafts or excessive dryness. Evaporative cooling systems also relying on psychrometrics. They lower dry bulb temperature at a constant wet bulb temperature, which is easy to visualize on the chart. This helps predict how effective these coolers will be in different conditions. In practical terms, engineers plot air conditions at each stage of the cooling process on the psychrometric chart. They check how air moves from the initial state to the final, ensuring the system is sized correctly and energy is used wisely. This visual tool makes it easier to see how heat and moisture are transferred and controlled. Overall, psychrometrics links heat transfer, moisture control, and air movement into a clear picture. It helps engineers design cooling systems that are efficient, reliable, and comfortable for indoor environments. Without it, managing indoor air quality and thermal comfort would be much more guesswork.